In the next 2 weeks, we're going to learn a very important part of this. Normal probability distribution is the most important distribution in statistics. It is the foundation of all other chapters after this one. Meaning that if we are not familiar with normal distribution, we will have a lot of difficulties when we learn, for example, chapter 7, 8, 9, 10, all the way down. So please spend as much time as you have on this chapter. First of all, you might have the question, that is, what is distribution? What does it mean anyways? Let's look at an example. In the early chapters, we see a Hudson auto repair, and here is the sample of parts cost for 50 tune-ups. So we have different numbers here. Okay, we have a lot of numbers here. As we learned, I believe in chapter 2, we can draw a dot plot. And basically, we draw a dot. For example, here, when we have a number 52, we draw a dot here. Here, if we have 4 62s, then we draw 4 dots, one on the top of each other. And then we do the same thing for all the numbers. If we line up all the dots on the top, okay, line up the dots and fill up the gap between those dots and this axis here, the line here. So we see our shape looks like this. And when we skip all the details of the dots, the shape here is the so-called distribution. That is the idea. That's how we understand the distribution in statistics. Now come to our normal probability distribution. It looks like this. Basically, the shape looks like this. This shape is symmetric. The size of the area in between this normal distribution curve and the x-axis, which is the one, the area we're highlighting in red here, is the probability. So the total probability of normal distribution is 100%. In other words, the size, the physical size of the area here, which I highlighted, the physical size of this equals to 1. In other words, 100% of the chance. Now we have the normal distribution. And on this curve here, this curve, the highest point on this curve is, it locates on this x-axis, locates in the middle. It is the mean of normal distribution, which is also the median and the mode of this normal distribution. Put it very simply, this point is the middle of the normal distribution. Now, if we split this highlighted area under the normal distribution curve into 2 parts, we split it right in the middle where the mean is, then the left half part, the size of the left half is 0.5. The size of the area on the right hand and the right half part is 0.5. And of course, 0.5 plus 0.5 equals to 1. Now we have the normal distribution curve looks like this. Mathematically, this curve is a function. It is determined by a formula. And here's the formula. The formula is fx, which is the value of this curve, equals to 1 over sigma times square root of 2 pi times e to the power of negative x minus mu squared divided by 2 sigma squared. Now, in this formula, mu is the mean of this normal distribution. Sigma is the standard deviation of this normal distribution. Pi is a fixed number. It is 3.14159. So anytime you see a pi, it is just a label for this number here. Okay. Now E equals to 2.71828. Every time you see a E, it is in mathematics, it's basically this number. There's nothing special about this. Just give a number a special name, special label, because we use this number a lot in mathematics. So for convenience, we name this one as pi, this one as E. Now, this formula here, we sometimes call that a normal probability density function. In this class, in this course, we don't need to, we don't cover what is a density function at all. Instead, we need to learn how to use normal distribution. By the way, a lot of times we see a relatively complex formula. We got scared by it. Now, what happens is in this class we do not use this formula too much, and this one probably will not show up too many times. And the good news is, in this class, you do not need to memorize this formula. You do not need to even know how to use this formula to calculate. What we need to know is, if we look at this formula carefully, there's two variables, two things that we really don't know. That is mu and standard deviation. All right. So others we all know. Okay. For example, this is the one we don't know. This is standard deviation. This one is a pi. We know already. E we know. Mu, which is the mean, we don't know. Sigma we don't know. X is the variable that the axis, horizontal axis here. Now, in this formula, in this function, there's only two things we don't know: mu and a sigma. Since in this function of normal distribution curve, there's only two things we don't know: the mean and the standard deviation. So in other words, if we know the mean and the standard deviation, then we know what a normal distribution looks like and where it is. Let's look at the mean of the normal distribution. Okay, the mean of the normal distribution, for example, can be -10. So the middle is here. We have this curve. Or be 0, then we have this purple curve. That's normal curve. Another normal distribution, the mean is 20, it is here. So this is another normal distribution. In other words, the mean of a normal distribution can be any numerical value. It can be any. It can be negative, it can be 0, it can be positive. Other than mean, we also have this standard deviation that determines the normal distribution. Recall that in a past slide, the mean determines where the middle is of a normal distribution. Now, standard deviation is slightly different. For example, this gray curve here has a standard deviation equals to 25, and this green one, or actually say blue one, the standard deviation of this curve equals to 15. So you will see, if you see a lot of normal distributions, you will find out that if the standard deviation is smaller, this curve is taller. Okay, if the standard deviation is bigger, then this curve is wider. Okay, so recall that what is the idea, what is the understanding of a standard deviation? Standard deviation tells us how wide all the data spread around the mean. So the bigger standard deviation, the spread is bigger. The smaller standard deviation, the spread is smaller away from the mean. So that's a standard deviation. Let's summarize. The mean determines the center location of normal distribution. So if the mean is here, the normal distribution is here. If the mean is here, the normal distribution is here. If the mean is here, the normal distribution is here. The standard deviation of a normal distribution determines the width of the curve. So obviously this one was a larger standard deviation. The curve is wider comparing to this one. And this one is wider than this one as well. These two variables or parameters will determine everything about normal distribution. What are these two parameters? The mean and the standard deviation. The mean and the standard deviation. So if the mean is here, standard deviation equals to 25, then the curve is always looks like this. If the mean is here, then we know that the normal distribution is here. And if sigma equals to 15, and this is how wide this normal distribution is. So this one is the location of this curve is determined by the mean as well, and the width of it. And the width of it is determined by sigma. So in one word, mu and the sigma, the mean and the standard deviation determines everything about a normal distribution. So the other thing we need to know is the physical area of the physical size of total area under the curve is always 1. For example, the physical size under this purple curve is 1. The physical size under this curve is 1 as well. Okay, the physical size under this area and above x-axis is 1.